take a wee cotton bud, and you really have to braid the scalp a bit through the cap there, and you might even kind of redden the tissue a little bit as a result of your work there. So it's not a great idea. So now a lot of other systems don't really. Most people do try and match 20 kilo. So what else do I want to say on that? I'll leave these guys away for yeah. So the BioPack then is basically it's a more flexible. It's a data acquisition system to which you just modular, to which you can plug in a whole lot of physiological measurement units. We've mostly disconnected up to biopotential amplifiers of one variety or another. When I talk about variety, you might say, well, what have we learned about? Why don't we just get a really, really good EEG amp? You know, it's got really high common mode rejection ratio, really high gain, and use that for everything. Yeah, you could, but they're more expensive, and so generally, generally you'll find that you know, for ECG or for EMG, you might not need quite that quality, but also if you have to whole lot of buttons and switches, you might say, well, that's a lot more than what I would expect. The reason is that some of this includes hardware filters and hardware to remove state baseline wander, or for example, let's have a look. So this EEG amp, you can't see up close, but you come up close at the end. It's got some settings here. The top setting is there's a zero setting. It's for zeroing the amp. We can't send out any offsets. There's gain. Gain settings are 5,000, 10,000, 20,000, and 50,000. And that's quite extraordinary gain. Okay. And you can imagine if you're obviously that 50,000 setting. If your common mode rejection ratio is poor, that's going to cause your 50 Hz just to saturate your amp or your dominant signal. Okay, but look here. Next, it's got some built-in low-pass filters at either 3 kHz or 10 kHz. Quite high. And it's got a high-pass filter that you can switch on or off, and it's at 100 Hz. We would have it set off for our EEG, because if you're using this for EEG measurements, most of the signals of interest are down below, say, 50 Hz, so probably like, you know, maybe from 0, which we're talking about CMB, up to about 30, 40 Hz. And then another high-pass filter that we can that we have at 20 Hz and at 1 Hz. 1 Hz is useful because it removes baseline wander. Okay. And then we have where electrodes go in. This does a bipolar measurement, so there's two electrodes and a reference. Okay, but you might say there's more holes there than that. That's because we looked at that the last day in the lectures. Remember that we get an artifact as a result of capacitive pickup between, say, the mains and the leads themselves, and one way to reduce that was to shield the leads. Okay, and ground the shields, or in this case you actively drive the shields with a signal that's the mirror image of the signal you're measuring, or an average of, to try and reduce the capacitive effect. So, that's why if we look at here's some leads. These are just, how to say, single versions of that, I suppose. It's just a lead. It's just a, it's just a lead. Again, these are like 20 quid each or 40 quid each, aren't they? Or more. Ridiculous. So this is our shielded pinch lead. So it's a pinch lead purely because this is how it attaches to an electrode. Is this a new packet?
Yeah.
Wow. Right now, all the stops for you. So this is basically a pinch. You just pinch that to mechanically move it so you can just clip it onto your electrode. Okay, that's just a pressure contact. And the lead itself has got a input and shield. That's the shield. Okay. these in a minute. What else have we got along here? We have galvanic skin response, which we didn't really look at in the course. We alluded to it. Basically, where we get a measure of autonomic nervous system activity by passing a current through some sweat pore dense part of the body and measure the changes in conductance, which occurs as the autonomic nervous system sends volleys of activity. That's the basis of your lie detector, so to speak. It's a stress signal. So this GSR is a kind of a funny amplifier because it's basically it allows a conductivity measurement to be done. So it's not a biopotential measurement like these other amplifiers. So we'll skip this guy because we want to stick to the biopotentials. There's another evoked potential amplifier, ERS. That means we now can do 4 channels. Then we have an ECG amp here. Now, so if you look at this, the ECG amp is essentially, the gains now are an order less. So they're 500, 1000, 2000 and 5000. Now, and this is why it's a separate unit. I mean, a separate unit partially, you could, if you're very cynical and, I say for marketing reasons, but that's not totally fair. But it's got a few integrated ECG specific functions. It's got an R-wave mode, it's got a normal mode, it's got some filtering that would be pertinent for ECG, and that's a low pass filter, 35 Hz, it's got a high pass filter, and again some cheap little electrodes. Then we have another evoked potential amp that we just happen to have plugged in here. You just stuck all these together for the crack, was it? Yeah? Yeah. And there's an EMG amp here. Now what's the EMG? Well, it looks very like the ECG in terms of gain. 500, 1000, 2000, 5000. You know that the EMG and the ECG, they're all an order of magnitude greater in amplitude than the EEG. So that's not surprising from the gain point of view. And it's got some built-in filters that would be pertinent for the EMG. So some low pass filter at 500 Hz, 5 kHz, and high pass filter at 100 Hz, and another high pass filter at 1 Hz. And indeed, this is very like the ERS or the evoked potential amplifier. And we have a respiratory amplifier here. It's for if you want to capture respiration measurement. And basically, what we have there is basically a band you put around the chest, and so it's a kind of a, plus it's mammography measurement, a volume measurement. So as your chest expands and contracts, it stretches the belt. And so this guy here, not unlike the galvanic skin response, GSR amp is passing a current through it and measuring the change in potential, i.e. it's measuring changes in resistance. And that's recorded. And then the last amp here is a PPG unit, which will allow you to do a photoplethysmography, to allow you to see essentially blood volume changes over time optically by shining near infrared light and measure the perceived blood. We might actually have a look at that just since we've spoken up about PPG and you should have it in your assignment. I think it's in there, isn't it? Yeah. So let's just, for the sheer fun of it, we'll use the EEG amp for everything, right? We just turn down the gain if it's too much. So we'll do we'll do some ECG and then we'll do some EMG. And we probably won't do EEG, it's just too hard, we'll see. Because you know, have to put in some shit in there. Looking at you, Philip. Maybe electrodes need to go on. Yes. Breathe in too much air. Right. But so something else the PPG will do then as well. My fingers are very cold for some reason. PPG won't go well with cold fingers and poor circulation. Right, Darren, will you be the guinea pig?
Sure.
Yeah. And then you see all these stuff. Once I say go, you can come up and we wander around. Oh yeah, when Darren comes into the electrodes on yourself, just here and we have pictures. No, I can hear it right now. Or but yeah.